Here we have an example of a complex number equation. We're asked to find x and y given the following equation. The left-hand side of the equation needs to be expanded first. It has 2 times 3 minus 5yi within it. So we might expand, and if we can, simplify the left-hand side first. So we have an x plus 2y, then 2 times 3 is 6, and 2 times negative 5yi is negative 10yi, and that equals 8 minus 13i. Now the rule for a complex equation like this is that the real parts must equal the real parts, and the imaginary parts equal the imaginary parts. So let's identify the real parts first. We have the x, the 6, and the 8. These are the parts with no I in the term. So we have that x plus 6 must equal to 8 if the real parts equal the real parts. Now we can finish off this. If x plus 6 equals 8 and we take 6 from both sides, x must be equal to 2. We do something similar with the imaginary parts. The imaginary parts must equal the imaginary parts on the left and right hand side of the equation. So 2i minus 10yi must be equal to negative 13i. Now there was no need to write the i's in each of these. I is a common term, so if we divide across by I, we could have just written that 2 minus 10y equals negative 13. If that's true, what we might do is add 10y and add 13 to both sides of the equation, giving that 15 is equal to 10y, and dividing across both sides by 10, that gives us that y is equal to 1.5 or 3 over 2. So we solved the complex equation using the rule that the real parts must equal the real parts and the imaginary parts equal the imaginary parts.